Sup guys, welcome to today's show. So, today we are going to code a little bit of assembly and C because I'm going to code my own calling convention. So I will be able to run assembly programs or subroutines as they are called to be able to run them directly from C code. And there is already a calling convention. But it doesn't work very good, I think. There are always trouble with corrupt stack and all different things. I will still show you how it's done according to the C standard or whatever. But I'm gonna focus this episode's coding segment on creating my own calling convention. And I will simply call this program CV for coding convention. Right? So, how will this look? Maybe I should sketch it up a little bit. So let's say I have an assembly function or subroutine which is called, let's say, encrypt. And encrypt takes two values, two strings basically. So if we were to define it as a C function, it would be something like int 8 star and then encrypt, and it's going to take an int 8 key and an int 8 message, and then it's going to encrypt this message with this key and return a pointer to a string with encrypted data. Simple enough. So how do we give these arguments to that subroutine, and how do we get the return value back? Well, I was thinking we will code a function or a macro perhaps, which will be something like call. We could just call it call. And then we give the name of the subroutine, encrypt, and then we give them an argc and an argv. Same as we were to give it if it was a main function in C. And how do we define these? Well, the encrypt is going to be a function pointer. So it's going to look something like, I think I'm going to do it like int32, and then well, let's not put encrypt here, let's put something like function, because it should be able to handle all functions or subroutines. By the way, subroutine is the same thing as a function, it's just assembly terms, basically. Alright, so we have a function, and it's going to have a variable number of arguments. And since it's going to have, let's see, what's the best way? Maybe we shouldn't do it like this. Maybe we should just give these an arg. Let's not put a lot of different things on the stack that will just break. Uh, or maybe, I think I'm going to change my mind again. When we call it with our call function, this is what we're going to send. However, the argument to the actual function that we're going to call, it's going to have just one argument, and that is the arg. And what is an arg? Well, I would like to define it as a structure, actually. Something like this. So we have an int 8 with the or maybe not an int 8. Let's use an int 32 for the argc, and then we will have an then we're gonna have a void. I'm not sure if we can do it like this, but I would like to have something like this. An array to void star without a size. And then we were to type def this struct as, I don't know, arg or something, or args perhaps. Yeah. So this would be the signature pointer to an arg. Right. So our call function or macro, I haven't decided, will need to take this input argc and argv, allocate a structure of this kind, pass it to this function, and then inside the function we will allocate to this, fill in the argc and argv, and then we will just set fn equal to, or that's not even necessary, we send it as an argument. We will simply call this thing with our args and handle the return value. And what about the assembly side of it? Well, we will define two macros, one which will handle the input, and that will be something like, well, I want to put inside of the EX the first argument, I think. Or maybe we should follow the Linux system call convention, because in that case EX is being used to decide what system call to call, and there's not really a resemblance here, but let's say EBX is the first argument, and then we have ECX as the second, EDX as the third. What comes next? I think it should be let's see. Oh, my head is spinning right now. It is. What do we have? We have EBP, we have ESP, EIP. Let's just check. Let's break on start, run, info, reg. Right. We have ESI and EDI. So ESI is first, and then EDI. Or maybe other way around, EDI, ESI. I think this is the right way. So we will be able to handle 1, 2, 3, 4, 5 arguments. And 5 arguments ought to be enough for anyone, don't you think? So we will fill these out with the help of this structure, or however we decide to define it. And we will probably be a little bit more specific with these things. So this will be a register int, and maybe this will even be a volatile void. We'll see. But this is basically the idea. And in order to handle the return value, we will just make our lives easy, I think. Well, we could actually reuse the input, but I'm not really sure what I think about that. And if we're going to follow the calling convention of the system calls, we should put the return value inside of EX. So that's probably what we should do. All right. So where do we begin? Do we begin at the C side or the assembly side? I think we're gonna start with the assembly. So let's use bash bs and create a project called calling convention. That's CC. Yeah, that's good enough name. And I'm going to use the default Asm, which is new inside of bash bs 1.1, which I probably hopefully remember to update on the repo before I publish this thing. But it's quite a simple default. I'm going to show you in just a sec. I'm just gonna set my home to this thing. Alright, so we have a make file and we have a CC Asm and a CC Asm H, which is an include file. So let's open this up. Let's see, we have CC and we open in editor. And let's open all of these. And let's see. Alright, so we have a simple make file which just assembles this cc.asm and then it links. Nothing special. Creates an elf binary as output. The asm h is pretty empty. And let's not forget to change the I'm not even sure what it's called. The interpretation, perhaps, from a plain text file to an ASM file, because it does not recognize the ASM H extension. And this is the default ASM file. All we do is include the ASM H, set the bits to 32, export the start label. We have an empty data section, and then we have the text section with just a no op, and then we have an exit. So that's all. Alright, so how do we do this? Well, let's start by doing this manually inside of this ASM file. And then when we have done that, we can create a separate macro instead. I think that's the best workflow. So let's see. We need to first do some example function which we need to export. So, well, let's create this encrypt function, and I'm not really gonna encrypt it, but let's create it anyway and do some, I don't know, some XOR stuff or something. So let's see, maybe we can even put a halt here. We shouldn't reach this point anyway. So let's say we have this encrypt function or label or subroutine even. And I don't really like the indentation here. I think I want to have a space here, put the labels to the left. And let's also jump out 2 steps so we can have room for sublabels. And I also think, let's see, maybe we need a BSS section as well. Yeah, let's do that. section BSS, and we want this to be no exec, and I'm not sure, should it be a comma here? It's been a while since I coded assembly, but I think so. And we should have write access to this one. And same with the data. I don't know, maybe we need to specify read as well. And the text section should be exec and read but no write. Let's see if this compiles. I'm not sure if the syntax is correct. It most definitely was not. So what if we replace this with space? Will that silence the compiler inside of quotes? Okay, it doesn't recognize read. I guess you can't even make it no read. That would be pretty weird, right? Alright, so now it compiles fine and we can even run it without a crash. That's good. Alright, so since we are going to use this encrypt function inside of C, we want to export it as well. Let's do that. And let's see. Maybe we should even put this inside of the Asm H file. Let's see. Should we do that? Maybe not. Alright, so we need to define this structure, and the syntax is pretty weird for structures, and I don't really remember how to do it, but let's try. So we're gonna have a struct which is called args. And how do we do this? I think we make sublabels for the different contents. So we're gonna have an argc, and we need to specify, is it the number of bytes? Yes, maybe. Let me consult one of my older projects. Let's go to code and run lock. Where do I have it? Asm run block here. And where did I put it? It must be inside of the Asm H, I suppose. But it wasn't. We grep struct inside of all Asm H and Asm util.asm, okay? Maybe it's not even called struct, but we have something called pw state. So let's grep for that. Pw state inside of our asm h. There we struct. It's called struct. So why do they name stuff that weirdly? PW state. Alright, so I almost remembered it right. We do these sublabels, as you see, and we reserve the number of bytes or whatever. The only thing I forgot was that it should be struck and not struct, and it should end with end struck. Alrighty then, let's carry on. So struck args. Let me just double check one thing. Yeah. Alright, so we have argc, and let's space this out a little bit. And we will reserve one double word for the argc. That's 32 bits. And what about the other thing? Well, how many arguments did we say we were? Never mind. We define this as this void argv like this. So this is an array of pointers to arguments. Maybe that's not the best way. Maybe we should just do void double star argv instead, because then we can simply do argv res d1 here as well. I think that is better. Let's start there anyway. And then we do end struct, like so. Alright, so now we have a structure. And now we need to turn that structure into something interesting. So let's see, we need to handle this a little bit differently depending on the number of arguments, since we're going to put it inside of different registers. It's almost as if we need to do something similar to an if statement for each case. I think there's no way around that. No, I guess not. Alright, so let's see. Let's start with the argc. That's the easy thing. Um, let's see. We should be able to do something like this. Argc is equal to stack point. Um, Stack pointer plus, because if we do it like this, then we point to the top of the stack, which should be the return address, right? Which means we should probably do ESP plus 4, because that's the size of the return address. So we want the next thing. So that's our argc. Now that we have an argc, we can compare that to, let's see, how many arguments did we sign up? We will have EBX, ECX, EDX, EBX, ECX, EDX, and my brain is not really functioning today. Right, it's EDI and ESI. EDI, ESI. So 1, 2, 3, 4, 5. So if we compare argc to 4, let's see. If we were to use the regular C main and supply one argument, then argc would be 2, because the first argument is the name of the program, basically. Do we have something similar here? We could put the name of the function, but there's not really any point in doing that. But we don't want to deviate from the standard either. So let's say argc is one more than the actual number of arguments. So if we have 5, then argc would be 6, and we want to compare if it's bigger than 5. So jump if greater than. Let's see. Maybe we should do this. I think we need to define some sublabels here. So let's jump out and let's say this is init, and this first case is, let's call it args5. So this is if we have 5 arguments, which means that we should compare this argc to 5, and we should jump if it's less or equal to. Then we should jump to args4, and we should not do anything else. However, if we have 5 arguments, then we want to take care of the 5th argument, right? So let's put into some register. We can use EBX, for instance, and let's put the size of each pointer, which is 4 bytes. And then we want to multiply. I need to check one thing, how this mul works. How this mul instruction works, because it just does only take one argument, and it multiplies with, let's see, M32. It multiplies with EX. And EX is also the destination operand. So the source operand is the actual argument that we give. Okay, so into EX we put, let's see, what is argc? In this case, when we have 5 arguments, argc will be 6. But we don't want to jump 6 steps, do we? Because EBX is going to be the argv plus 0. And then we have plus 4, plus 8, plus 12, plus 16. So let's move into EX, our argc. And then we decrease EX, so it goes from 6 down to 5. But that's not enough, is it? Because we want it to be 16. So let's do a sub instead. So we sub ex 2, and then we multiply with ebx. So this should be 4 times 4, which is 16. And right. And then we need to calculate the actual address to the pointer we are interested in. So let's see. We need another EQ. We need args, EQ, ESP plus 8. Or am I wrong here? Because we're not passing 2 arguments on the stack. This first one is a pointer to this thing. So maybe we should just call this arg. Yeah, that's more like it. But where do we put the argc and the argv? We need to have a BSS section after all, I think, or use it. So let's say we have an argc, and this argc we reserve one word, 1D word. So arg is pointing to the structure, and we need to get inside of that structure, which means we need to move into ex the address of arg, and then we move into ebx the address of our argc. And then finally we move into the address of argc. Let's see. Move into the address of argc. No. We move into ebx. Let's see. Move into ex the arg. So that is a pointer. So we move into ebx the value inside of EX. And then we can move into ECX, our argc. And into so now EBX contains the value we're interested in. ECX contains the address of where we want to put it, which means we can move into the address of ECX the value of EBX. That must be the right thing to do. So then we at least have the right argc. But how do we handle the argv? And how should we define it here? Well, we do know how many maximum arguments we can take. And that is 1, 2, 3, 4, 5. So we could say argv reserves 5 double words. And then we can just repeat this stuff for each of them. That must be the best way, I guess. So let's see. If we move into EX, our argc, which contains a number of arguments, 6 in this case, we subtract 2, so we're at 4, and we multiply the 4 by the constant 4. So we're at 16 here in inside of EX. Then we add into EX our argv. So that is the address of argv. For the let's see. Yeah, since we add to this, this contains the correct argv, the 5th argv. So now we need to grab the value from it. But how do we manage this in a way so we can actually put them inside of the registers that we want to? We must use some kind of intermediate registers, I suppose. Yeah, I think that's the best way. Yeah, let's do that. So we will also reserve. Let's make our lives easy and just give it different names. So let's just call this What should we call them? Let's do underscore EBX, and we reserve one double word, and then we paste this in, and we do the same for ECX, EDX. We do it for EDI, and we do it for ESI. So now that we have the address to the argv that we are interested in, we can move the value into EBX, say, and now we can move into ECX the address of the register that we want to put it into eventually. And since this is the fifth argument, this should be ESI. And now we just move into no, should be like this. And now we move into ECX the EBX. Alright, so now we have handled the first case, which is when we have 5 arguments. Maybe we should do some controlling as well. For instance, let's call this sanity or sanitize. No, sanity is good. So we want to check that we don't have more than 5 arguments, because we can't handle that, which means that our argc should not be bigger than 6. So let's compare. By the way, we can probably argc. Yeah, we need to take an intermediate step here. We need to move into EX argc, and we need to compare let's see, we move into EX argc, we move into EBX the value of EX, and now we compare EBX to 5. That must be it. Alright. So we do the same thing here then. Move into EX, or we still have it, don't we? Because we moved into ECX the argc, and we move into the contents of argc we put here. from EBX. So EBX, let's see, we move the EX, the argument. And into EBX, the contents. Okay, so EBX at this point contains our number of arguments. So we don't need to move, we can just compare EBX to 6 and jump if greater, and error. Otherwise we continue. So let's put error on top. And what shall we do if we error? Well, we want to return something. Let's for now return a 0. So we move into EX number 0, or maybe we can just XOR EX with itself, and we return. And we don't want error from the beginning, so we jump to init, like so. Alright, it's starting to make sense. So if we have more than 6, then we jump to error. Otherwise, we just continue down to the args5. And we handle the 5th argument. So how do we handle the 4th argument? Well, we basically do the same all over again. Yeah. So we can just copy this, and we're gonna do it a bunch of times. So let's just paste this in. Couple of times. args5, and this will be args4, and args3, this is args2, and this is args1. And what do we need to change? Well, we want to compare a 4 in this case, and if it's less or equal to 4. Let's see. If it's less or equal to 4, it means that we have 4 arguments. Did we do something wrong here? Oh, I missed one. Let's remove that to begin with. But what about this args5? If we have 5 arguments, which we can handle, argc will be 6. And this checks if it's less or equal to 5. So if it's not 6, yeah, it's okay. So we'll do the same thing here, but we'll compare it to 4 instead, and we'll jump to 3 if it's less or equal to 4. Otherwise, we go through the same steps. And the only thing we need to change is the destination register. So instead of ESI, this will be EDI. And then we have the args3 case, which means this should be decremented to 3. And this too. No, wait a second. Here we have 5, 4, 4, 3. This should be 3, 2 then. And the destination register should be EDX. Then at the args2 case, this should be equal to 2, and this should be equal to 1. And the destination register should be ECX. Then we come to the args1 case. So what do we do here? We check if argc is less or equal to 1, which shouldn't even be possible. So we don't need to do any check here at all. However, we do need to do a check when we sanitize. So first we compare if it's greater than 6, but we should also compare if it is less than 2. Or should we handle 0 arguments? Yes, we should probably do that. Which means the only thing we need to check here is if EBX is equal to 0. And if it is, we can jump to error. So as long as we have 1, 2, 3, 4, 5, or 6, it's okay. But if it's more than 6, or if it's 0, then it's an error. So all of this code just to handle the arguments. And we're not even done yet, because now we need to move it into the right registers. So how do we do that? Let's create a label. Let's call it registers. And we move into EX, the address of EBX. That is the first argument. Now we need some register. No, we can probably just do move into EBX EX, right? And then we do the same again. We move into EX, the ECX. Then we move into the real ECX, EX. And then we do the same thing for the EDX. So we move into EDX our EX. And we do the same thing for E. Did I forget to change? Yes, I probably did. Let's see. So here we multiply EBX. We don't need to do any multiplication in this case because we're already at the right position. So this code will be a little bit different. Maybe I should just rewrite it. So we don't need to move into EX. We don't need this. And we don't need this. We don't need this. We don't need the multiplication. We still need to move into EX the argv and move into EBX the value. Then we move into ECX. This should not be ESI, this should be EBX. And we move into ECX the EBX. Okay, that's correct. So let's double check so I didn't miss one of the other ones. So ESI, EDI, we have EDX, we have ECX, and we have EBX. Okay, that's good. And so where were we? We did EBX, ECX, and EDX. Next in line is EDI. So into EDX we move EDI, and then we move into EDI, EX. And finally, we move into EX, ESI, and we move into the real ESI, EX. Alright, so after this step, all of our input registers are filled with what we want. A lot of code, but pretty nice anyhow. But I don't think it's a good idea to do this every time we call a function. So let's, instead of calling this encrypt, let's call it setup. Maybe that is a reserved word because I think there's an instruction called setup. We'll cross that river when we need to or something. This should be one step in. Okay, so this is our setup. And this is the first thing we need to do when we run any function. So if we have, for instance, the encrypt function, the first thing we'll do is call the setup. And now all of our registers will be as they should be. We do, however, need to check if EX is 0. So let's compare EX to 0. Jump if 0, error. We'll have an error. And we'll basically just forward this. So we will XOR, but EX is already 0. So we can just return here. Let's jump past this to init. And this is init, and we need to jump in. We call setup we check if ex is 0. If so, we jump to the error. Otherwise, we can start doing what the function ought to be doing. Alright, so this is the setup. We need to have something at the end too, don't we? Or should each function handle that? Well, since we're gonna return using the EX as an output register, it does not really matter where we do it. So we can do it inside of each function actually. Alright, a lot of code. I wonder if this even works, but I hope so. Does it compile? Bad syntax for EQ. Should we make this a label perhaps? Or is this the problem? Yeah, I guess this only works for constants. Maybe we could do something like define arg to be this. I guess that should be basically the same. And now it compiles. Splendid. And it does not crash when we run it. But that's probably because we don't even do anything with this quite yet. We did not really make use of our struct though. Perhaps we should. Let's see. We define arg to be this. So this is our struct basically. And I guess this syntax should be arg plus dot argc. And what about argv? How do we access the first argv? Take argc. Okay, we take argc as a starting point. But that's not quite right, is it? Wait, we add to ex arg v. What we should do is we should probably I guess we should move into edx our args plus dot argv. And then we add ex and edx instead. And this should be the same for all similar cases. So the move and the add, and it's just the add we have here. Can we paste into this? Seems like. So we move into edx args plus argv. So that is the address, and then we add ex, and ex is the number of arguments plus 2. Yeah, minus 2. So 6 becomes 4. And then we take this. Yeah, I think this is right. So instead of this, we should have this. And same here. And same here. Add EDX. Should it really be add in this case when we would just have one argument? What exactly are we adding to? Move to EDX. Because this should just be args plus 0, right? Add EDX. I think we can just use EDX directly here. Yeah, that should be better. Alright. And we also need to return here at the end. What about the return value from this? Well, we only need to return something non-zero. So something like this. And then the actual return value will be handled by these things inside of the actual function. Yeah. So let's say we provide two numbers and we want to plus them together and return them. That is our encrypt function, just for example. And so the only thing we need to do basically is move, no, we can add them directly. So we add EBX and ECX, the first and second arguments. And we move the result to EX. And then we return. Easy peasy. And I guess we don't even need a macro. Still compiles? No. 43. Okay, it doesn't like the name setup, I suppose. We can name it Prelude. So we'll call Prelude. No, that's not it. Comma decorator or end of line expected at 43. What? Why? Prelude colon. What am I missing here? Encrypt error inconsistently redefined. Well, that makes sense, since this should be another function. What if we just do ABC here or something? Still complaining. But we didn't even change much. Is it something with this? No. Is it because it's not exported? But that shouldn't matter, right? Weird. What if we do make clean first? What is this? What did we change? Well, we did do a little bit of this arg plus kind of thing. Could that be it? But why would they complain about this? How do I access structures inside of runlock? That might be interesting to see. If we go to code and asm and runlock, and what did I call that? Struct kind of thing. PW state. Okay, I used parentheses. And what about this I struct? I struct. So inside of the header file I have a struct, and then I have this I struct. So I guess the struct is like a blueprint, and this is what actually contains the values inside of the memory. And this is the label that we should refer to then, I guess. Alright, makes sense. So let's change it. Maybe we can even name this setup again. And let's fix this. Alright, so where should we put this I struct kind of thing? I guess we need to put it inside of the data segment. I wonder if we can call it the same. We can certainly try. So then we have an I struct. And it's called arg, right? Args. So I struck args, and Okay, at dot blah blah blah. So at dot argc, we should have a dd with a 0, and at dot argv, we should have several of these, I guess. Something like this. And then end I struck, or I end. Weird syntax. Really weird syntax. Okay, so then we reference this thing. Which is called args, same as our iStruct. Maybe that's stupid. Maybe we should call this sargs and sargs. Same error. We should have those parentheses as well. When we access them. So let's see, let's search for plus. So when we access this, let's see. Change into this MP. No. Undo. Change into this and P. So args plus, I guess. Args plus. Args plus. Args backslash plus. There we go. Alright, so this should be changed. No. This should change into. No. Is it just change this, paste. Alright, so args plus dot argv. Same here, change this, paste. Change this, paste. Change this, paste. And change this, paste. Alright, that's all of them. Will it compile this time? Okay, at least we got another error. Times value minus 16 is negative at line 22 as IN. It's probably because of all of these. Setup.argc not defined. Let's check that out as well. That's 60. But we are talking about args plus this. Isn't that the way it's done? State plus PV state buff. iStruct. iStruct PV state. Well, I'm just grepping here. I thought the syntax looked weird. Okay, let's go into code, let's go into Asm V, and we do this again. No, what's it called then? Run look, and this again. Search for PV state. Okay, so this is what we have. Well, this is basically what I did, right? So I call this the state. Then I have an iStruct with the PV state at dot blah blah blah. iStruct at dot blah blah blah. So we have args at dot argc at dot argv, comma, and this dd. looks right. And what about the calling site? So parentheses and state, and then, okay, so we need both this and this, I guess. So maybe we should just call this data. Which means this should be data plus args dot argc. That must be it. So let's search for backslash plus backslash dot. So this should be data and this should be args. Data plus args. Data args. Data. Who said assembly was supposed to be easy? Well, I can't really blame assembly. This is this specific C and Asm assembler. Data plus args. And that's it. Alright, what about this time? Make clean, jump down a little bit, clear the screen, we run make, and boom. Still crazy. args.argc not defined. I struck S args. Should it be? Maybe we should change this back to args. Okay, now we're talking. Only one error. Line 22. I end. Times value minus 16 is negative. That's a weird message. I wonder if anyone has gotten similar error messages. So So let's see, Anasm and this here. Times value. So it must be these eye struct kind of things. That's using the times in some way. But what is the difference between struct and eye struct? Let's check the official Anasm manual. So Anasm struct. If I can even find the manual, is it this perhaps? I struck employee. At employee ID. DD2. Once you define the structure, you can create instances of it using iStruct and iEnd. So we would do a label employee iStruct employee at employee ID. Employee 1 plus employee ID. And how did I do that? data plus args, argc. So data args argc. I guess that's right. It's still this weird error message. Section data. Maybe it has something to do with this, that the names collide. Could that be it? Arg, argc. So how do we use these labels? Argc. Okay, I think I remember. So what if we put an underscore in here? And I suppose we need to do it here as well. And then we need to search for the accessor. So data dot or args dot. So this will be this. Alright, let's hope it works this time. Still the same. I struck, I end. What if we were to copy what they have? No, this should be here. There we go. Looks pretty similar to what I did. And then the instantiation. At args. I struck args at args, blah blah blah. I struck employee at employee dot id. Looks almost identical. Still reacts to this. If I remove this, will it complain about the other thing? No, it compiles. That's really weird, isn't it? Or am I crazy? Seriously, what is the difference? Is it the hex? Nah. How can this work but not what I do? What if I were to put this back and put this on top? Not like that, but something like this. Still at the same point. Well, either I'm crazy or this must be a bug inside of an Asm somehow. What if I were to change this name? Non-constant argument. Non-constant argument. Non-constant argument. Times value minus 16 again. But where does minus 16 even come from? Maybe the line number is wrong. Maybe it's when I call this thing, but I don't even call x. Data plus this and that. Is it because this is called arg, perhaps, and the definition affects this somehow? Ah, that must be it, right? No, it's not that either. But I need to take the argument pointer from the stack somehow. And this is just on the data segment. Oh, I don't want to troubleshoot this anymore. Let's suggest not use structs. It's not really assembly anyway. Let's do some pointer arithmetic instead. So let's see. The argument is there. So we want to take out the argc, so it will be moved to ex, the arg. Like so. And then alright, so instead of using this stuff, what we want to move into edx is well, we want to move the arg, right? So that now points to the argc. And then we add ex to that. And ex, if we have 6, or let's say we have, let's say we have 3. So minus 2, that is 1. Times 4. So we plus arg with 4. And that will be the first argument. That argc3 is the second. So if we do it like this, Well, I guess we should set this to 5 instead. No, this is number of bytes. This should decrement by 1. If we were to do this, and we want to get at the second argument, that would mean argc is 3. So we move a 4 and times it by 1. And we go from arg, and we add that 4. So arg plus 4, that is the first. No, let's see. We're at 3, minus 1, that is 2. 2 times 4 is 8. Yeah, I think this is right. So we can just decrement EX instead of this expensive sub operation. And we remove this, and we move to EDX arg. Let's see if I can remember those steps. So instead of the sub, we just decrement EX. Remove this. And we move into EDX arg. Yeah, I think it is right. So remove the sub. Let's do deck EX, remove this. And we'll replace this by move EDX arg and remove it. Same here, deck EX, but remove this. Move EDX arg. And here we can just move EDX arg. So let's see, this is the args1 case, which means argc, which is inside of EBX, I suppose. EDX. The arg. Well, I guess we should add four to EDX in this case. What about here? This is the args2 case, so we have two arguments. That means the ECX, yeah, I mean the RC is 3. And then we decrement it. That EX holds the address of argc. And where do we use it? We add it to the EDX. And the EDX has the argument. So EDX has the pointer to the ECX, to the argc. EX, EDX. Increment EX. So EX has the address, and then we decrement the address and multiply it by 4. So maybe it's smarter to do like this. We can move to ECX instead. And then we move to EX, the contents of ECX. So that is the number of arguments. Then we decrement it by 1. So 3 becomes 2. And we times it by 4. And we plus it to the address of the argument, jumping past the argc. Yeah, this must be right. So, same here. Move EX, argc. This should be ECX. and then move to EX, ECX. And in this case, we move to EDX the arguments, and that is the address of the argc. And then we plus 4. So now it's pointing to the first argument, and that we move into EBX. Into ECX we put the address, and then into that we set EBX. Okay, now I think it's right. So let's also clean out those darn structures and make our lives a little bit easier. For show. Boom, it compiled. It compiled. It compiled. It compiled. Alrighty, we probably solved it this time. So most of the assembly is done. Now we basically but we need to create the C file, which we will continue on doing right after this. Sup guys, welcome back. So yesterday we began coding our very own calling convention for calling assembly functions or subroutines from C. And we set up basically most of the assembly stuff. We have these, what should we call them, fake registers with the memory allocated inside of the BSS section for temporarily assigning the different arguments. Then we have an argv and we have an argc. Let's see, 5 bytes for the argv. Five, right. Yes, 5 words or double words, because we have 5 arguments in an array. That's correct. But I was thinking how we access this structure with the arguments that we pass to the function or to the calling convention. Because let's think about this. If we have, let's say, we have an args structure, and I pointed to that. And in C we allocate with malloc and whatever size it is. what do we get back? Well, P has some heap address, right? So maybe 80, 44, 12, 9E or something like that. Um, and I was thinking, what does ESP contain? That is a stack address, right? So ESP is something like, I don't know, 1, 2, 3, something like this. Maybe we should align it better. So we define arg to be ESP plus 4. So in this case, it would be 1, 2, 3, 4. So something like this. And how do we use arg? Well, we use these brackets to obtain the pointer inside. So this definition will basically have this value, right? And what do we do with this? We put it inside of EX, and then into EBX we put the address inside of EX. So we follow this pointer to this allocated structure. Alright, it seems fine, I guess. There are probably a lot of errors here because the troubleshooting wasn't very structured. Think we got it all, but I'm not sure. We will have to do some GDB probably. But let's cross that bridge when we need to. So we want to try to get this encrypt function to work. And what does it do? Well, it takes the first argument and plus it with the second argument and then return that value. Easy peasy. Now we just need to create some C code which is able to make use of this calling convention. So let's do that. We need to create, let's see, what should we call this? Perhaps calling convention API.c. Is a good enough name? So CC API.c. Let's also create an H. CC API.h. Like so. And inside of here, I'm gonna put the standard stuff that I usually put. So I need to have a couple of integers first and foremost. So let's create type def, and we need to have an 8-bit, an 8-bit type. So an unsigned char is an int 8. Why does it type def unsigned short int 16, type def unsigned int is int 32, and type def unsigned long int is int 64. Let's also define the typecast macros that I usually use. So we're gonna have a $C, which is char, and we're gonna have one for a regular integer. Then we're gonna have the different of our own definitions. So a 1 byte, that's an int 8 star. And why the star? Because I use int 8 star more than a regular int 8. So it's better. Int 16. Int 32. And int 64. Okay, what else? Well, we need to have a structure for this argument passing. So let's do struct s args. And this will contain an int 32 for argc. And then how do we define this thing? Because it can have a lot of different values. So I want it to be something like void star argv, and then an array which is not defined in terms of size. But I'm not sure if it's possible to do void pointers like that. We'll see. And then we type def our struct s args, and let's just call this args, like so. All right. And maybe we can include stdio at least for now. And we need to be able to malloc, so let's put in the standard ones. That should be fine. Let's see. And let's include our ccapi.h. And let's also modify our make file. So how are we going to do this? Well, let's start with the easy stuff. So we want to have a ccapi.o, and that's going to require a ccapi.c and a ccapi.h. We'll compile this by running cc with some possible flags, and -c, and we're going to take the first one of these as input. But we already have flags, so maybe we need to define this a little bit better. Let's say these are the Asm flags, and then we have C flags. And for now, I do not want any optimizations. We can have wall, and let's set the standard to C23. We need to update some stuff. This one. And this will be C flags. Alright, so then we have a ccapi.o. What do we do with that thing? We're gonna, in the end, we're gonna have a library, right? But for the time being, when we develop, it's easier to have an actual binary. So let's start there. So I want to have a ccapi, which depends on ccapi.o. And this will be compiled by running cc with the C flags. And we're going to take the input file and produce an output file with some LD flags. Well, with some possible LD flags. And our LD flags will be, well, we'll see. But this will probably also depend on the Asm stuff, right? So we're going to have cc.o here too. Yeah. All right. What about this one? We are producing an Asm binary at this point as well, but we don't really need to, I think. But let's still do it for now. And we're gonna do both CC and CC API. I think this will be okay. Let's see if it compiles as is. It's right. As you can see, I did with the brackets instead of quotation marks, and that was intended. But for that to work, we do need some LD flags. Or actually, we're gonna need both, but let's start with the C flags. So we're gonna search for header files inside of dot. Do I need to have a space or should I have a small h? A small h, I suppose. Or maybe it's not h at all. I know it is L, big L for... right, it's big L for libraries, but it's not H for header files, it's I for include files. Okay, now we're getting somewhere. Okay, the only thing it complains about is that we don't have a main function, and that's pretty true. So let's create one. We're not gonna have it when we make our library, but let's for now. Okay, since we produce two different binaries, we can't really do it that way. So let's not. We don't need to create any Asm binary. So let's just remove CC here and comment this out. And the rest should be pretty okay, I think. Now what? Okay, it still complains because we have multiple starts. And since we're not creating any ASM binary, we do not actually need to. We don't need to have a start. And now I think it's going to compile. Yes, it did. It doesn't do much at this point, but at least it compiles. Alrighty then. So our objective is to be able to use this encrypt function. And in order to do that, we need to create an API for our calling convention. So let's see, we don't need makefile open any longer. And it did not complain about this syntax. That's pretty cool. So we can have an empty sized array of void pointers. That's pretty nifty, I think. Let's create a constructor function for this args thing. So it's going to return an args pointer. Make args. And what input is it going to take? Well, we want this to be a variadic function, right? So are we going to use my library for that, or the standard C stuff? What's it called? x86 args. And how do we define this stuff? Unsigned int. Well, I guess we could use some variant of this. So we create a variable and we grab the base pointer, increase it by 8 to get at the first argument. Do you really need to take it in 2 steps like I do here? Yeah, I guess we do. Let's do something like this. Let's just call this x. So x is the thing where we will, well, it's an intermediate variable. Can we avoid that somehow? Maybe we can. Because I don't like defining variables inside of macros. What if we were to do some more Asm here? If we were to push, let's say, EBX, and then we do this, almost. We move from EBP to EBX. And then we add we add 8 to EBX. So now EBX should contain the address of the first argument on the stack, which means if we now do this, but instead of EBP, we take EBX, and not just EBX, but we take a pointer, the pointer inside EBX. I'm not really sure about the syntax when doing this. Well, this weird AT&T syntax that GCC likes, but I think it's a regular parenthesis. And where do we want to move this? Well, we want to move it to our x variable, this thing, the argument to the macro. And then we don't need any of those. Do need some backslashes though. Something like this, perhaps. I'm not sure if it's gonna work, but let's try that to begin with. So how do we test this? Well, we need a variadic function. So let's do something simple. Let's just take a function which pluses 3 numbers or something. So let's say we have an int 32. Add 3. And I'm not sure if we can do this without having a first argument, but let's try. So now we basically need to have an int 32. Let's say val and sum. And we have an int 32 pointer. Then we run args on p, which should now contain the first argument if everything works. So let's set val equal to that. And then we can increase this. And let's set sum equal to 0. And sum plus equals val. And then we can do this how many times we want. And let's return val. And then we should be able to do something like this. The sum is and what are we gonna send? We're gonna do add 3, and we give it a 2, a 5, and another 2, say. So hopefully this compiles and gives us a 9 back. It certainly did not. Maybe it's not 3 dots. Do we know any variadic function? Printf is one, right? Seems to be those dots. Maybe it's because we don't have the first argument. Let's just try. Something like this. Do we need to have a function declaration? Maybe we have an error somewhere else. We did not really finish this thing, did we? Let's comment this out for now. And this. See what happens. Okay. Now we're getting somewhere. Is it, what does it say? E big X 10. Line 10. In the C file. Okay. EEBX. Let's try to remove the include files. This is a good trick. If you need to troubleshoot a macro, comment out the includes, and then you run CPP on your C file. And hopefully it should, yes, it should expand the macro. All right, so this is what it's going to run. EEBX the line after the push. That's right. I missed it because of the colors. All right, let's see. Maybe it works this time. It gave us some warning, but it compiled. But it crashed. We didn't get much wiser here. Well, we're gonna need a GDB session sooner or later, so let's do it right now. So we go into TMP, we go into CC, set this to our home, we cat the regular home's GDB file, launch GDB against CC API. Oh, we can just do this. And we need to remove all the hideous colors and stuff. Let's start with this one. And we need to paste them line by line, which is quite annoying. One of these days I'm gonna compile my own version of GDB where I have fixed all these annoying security features. So let's see, we define an F function that resets the target exe file. It can run make. Now we set the target exe to our CC API. Now we set symbol file to our CC API. End. And I also want to define my XX, which is x/I. This is to disassemble the current position in the file. Well, in the running process, actually. So we take EBP minus 20 and we want to grab 30 instructions. Alright, so let's run F. Why did I do? Should have done just one. Okay, need to do everything again. Yes. So target exec and make and target exec CC API symbol CC API end. F. I did the same thing again. I'm retarded. So target exec make target exec CC API symbol file dot slash CC API and F. Good. Alright, so let's start this thing. And let's see what happens. It's segfault XX. And we are where? Move into EX the pointer of EX. And what is EX? 2. Okay, so that probably means that we are experiencing trouble with the dereferencing. Which makes sense. Because I wrote it like this because I was expecting a pointer because that is what we're going to use. But I haven't sent the arguments as pointers. But let's do that instead. So let's say we have x1, x2, x3. x1 is 2, x2 is 5, x3 is 2. And then we send the address of those things. So x1, x2, and x3. Okay, not exactly what I was expecting. So probably one of our variables is not. We're probably either we are too early or too late in the argument list. So to find out which, we could change this to a 1 instead of a 2, and let's see if this only changes by one number. Well, we can't really think like that, can we? Because it's random stuff on the memory. So we do actually need to experiment a little bit. What if we were to increase P once more? Then the sum is 0. That's a bit weird. That is a bit weird. Maybe we should cast this thing. And if we remove this, then we're back at that. So how can it return a negative number when we use unsigned stuff? Maybe we should make this in hex instead. It's usually more enlightening. Okay, that's a big number. And if we increase it once more, we get 0. What if we were to decrease it? Then we get 1. 1. Where does the 1 come from? Alright, let's do some GDB magic. Let's start this thing and set the breakpoint on add 3. Alright, so now we're here. And what are we interested in? We are basically interested in the EBP plus 8. So it contains another stack thing. And what about EBP as is? That does the same. What's inside of this? There we have the 2. So EBP plus 8 contains a stack address which contains a 2. Right, because we send them as arguments. So we get them on the stack like that. So what does it mean? We should dereference them twice? Is that even a thing? So we should make this a pointer to a pointer then, I guess? Can we do this? That would be pretty cool syntax if it worked. Maybe we need to add some parentheses or something, but oh, let's try. It compiled, but it crashed. It crashed. It crashed. Let's see. EBP plus 8. That's this one. And that's the 2. What about plus 12? Then we have another stack address with a 5. So I would guess that plus 16 is another stack address containing another 2. Any takers? Okay, so why can't we dereference them twice? Let's add some informational debug messages. So if we want to print some hex, and let's say we want to print can we do this? Well, we can certainly try. Then we get the 2. What if we declare this like this? What happens then? Still get the 2. Did it even update? Yes. What about without the cast? Still get the 2. And if we do this, we get a 1. What if we were to do just this? Okay, we need to cast. Okay, so now we have this address. And if we increase it by 1, does it jump 4 steps or 1 step? Hard to tell. Maybe they just changed. So let's do this instead. 8C90. I guess that's 4. It's not 1 for sure. Yes, it jumps 4 steps. And a pointer to an int 32 should be 4. So why did we get a 1 when we plus 1? What if we do -1? And maybe we should change these so it's different numbers. It's hard to tell at which point we are. A 2 and a 5. 2 and a 5. Okay. So the arguments are in reverse order. No. It's me who's just plain stupid, I guess. The stack is building upwards. But C arguments should account for that, shouldn't they? But now we are accessing memory locations directly through Asm instructions. All right. Well. What we should have done is this. So will we get a 10? No, we got a 3. A 3. Why? I'm so stupid. You probably saw this a million years ago, right? I'm returning val. I should be returning the sum, of course. Do I get a 10? I get a 10. But I want to see the actual 10 in decimal form and without the cast. The sum is 10. All right. So, okay. So now we can handle variadic arguments, and we don't even need a first argument like the C version of this does. Pretty nifty. Cool, cool, cool. So we can remove this stuff. This was only to try things out. What we really want to build is the constructor for make args. And this will just be like this. Isn't this a nice function declaration? I think it is. So how do we create an args structure from a variadic argument list? No, it's not like this, by the way. We do need the argc. Right. We could possibly have a null terminator instead. Wouldn't that be kind of cool? Yeah, I think it would. Because I want to keep this signature to the function. I like it. So we'll have an args, make args, and dot dot dot. And in this case, we're gonna have a void star arg, or p perhaps. We need an int32 argc. And we can do something like argc is equal to 0, or maybe 0, like this. And then we can just do while p equal, and then we use our args macro. Now we can do p equal, we do args p, I guess. And we need to change the type, because we're not dealing with, no, we don't actually. This is type agnostic. So while args p, what do we want to do? Well, we need to create an array. And we don't know how big that array is going to be beforehand. But we can allocate. We do have a maximum, right? We can't handle more than 5 arguments. So we can simply do void r 5. And as long as we have a p, we want to fill in our R array. So basically what we want to do is we want to set R plus argc equal to p. And we want to increase argc afterwards. And that's pretty much it, actually. So we want to check here if we have an argc which is not 0, or we want to check if it is 0. And in that case, we just want to return early an error. So we're going to return an args casted 0. But if we have an argc, we want to increase it once more, because we want it to be 2 if we have one argument, same as the main function usually do it. Okay, so now we have the array, and we know how many things we have. So maybe before we do that, we can calculate the size. before we increase it. Makes the calculations a little bit easier, because we can just take argc times size of void star, so this is for the argv part of the structure. And then we also need to have the size of the rest. So size of struct s args. So that is the size we want to allocate. Then we can increase argc. We can set, we can actually no, we can't. We need to have something of type args. So we set a equal to an args casted malloc. It's size. And if we don't have an a, we can also early return, because we should definitely have that, but you never know. And now we can just fill in the blanks, basically. Copy the stuff from what we have. So inside of A, we have an argc, which should be equal to our argc. And then we want to copy the whole array. By the way, can we really do this? No, we should only call args once. So we do args p like this. And inside of here we should do while p minus minus, I suppose. No, we need to do, and then while p minus minus. And if we don't have a p, we should all early return. Okay, this should work. I guess. And then we should get the stuff in order as well, shouldn't we? Don't remember if we did up here. Doesn't matter, perhaps. So how do we copy these things in the easiest kind of way? We could do a memory copy, but I don't want to use any libc functions. We haven't this far, well, except for malloc. which is kind of hard to avoid. So let's see. Guess we can do it in the other loop. So 4 and now I think we could reuse P. Did I delete that, by the way? No. So P is equal to our array plus argc. And it's 8, and as we want to loop as long as we have an argc, which is not 0. And what do we want to do at each iteration? Well, we want to fill in our structure. So something like A argv plus argc is equal to P. And then we want to decrease P and we want to decrease argc. And perhaps we need to dereference P as well. Yes, that's it. Don't think we need to do anything more other than returning this A thing. argc. Maybe we could put this on the same line even. A argc equal to argc. Because this does only happen once. So A argc should be equal to argc. And we use it to index into our array and set P to that. So then we fill in all the stuff backwards. But we need to take into account, though, this, that we have increased this thing. So maybe we should wait with the increase. And let's do it here instead. I think this will work. Maybe we should create some kind of print function as well, so we can see a little bit more what we're doing, because we probably need to troubleshoot this quite a bit. So print args, void print args, and this will take an args star. Void print args, and we'll have an args a. We need to have a loop. So for well, we can begin by printing. Let's do like we did it in another occasion. Let's call this print args prime instead. Same here. And then we need to take an additional argument, which is an int 8 star. Int 8 identifier. So we print the name, and we print argc. So 1, 2, 3. 1, 2, 3. And %d like this. We give the identifier. We need to cast this as a char. And we give the a argc, like so. Now we can set our n equal to 0, I guess. And we're going to loop as long as n is less than a argc minus 1. and n++. And at each iteration, we're going to print something of the kind argv, and the index is equal to, and the hexadecimal representation of the pointer inside. So we have an integer n, and we have an integer a argv. And I think that should be okay. So our main function will be something like this. We'll create an args structure. Let's see. Let's just call this A for now. And what are we going to put inside of there? Well, we can do the numbers we did before, but let's do it this way. So we have int32 x, y, z, and then we have a pointer for each of those. X pointer, Y pointer, Z pointer. We set X equal to 2, Y equal to 5, Z equal to 3, and we set XP equal to X, YP equal to Y, and ZP equal to Z. And now we create one of these args thing. And we just pass it XP, YP, ZP. Then we can run print args on A. And then we free A. And we return. And I call this print args prime with an identifier. That's why I want to create another alias or macro, which will be print args without the prime, and it's going to take an identifier, and we are going to call print args prime with let's see, the string representation of the identifier. We also need, let's see, well, we'll just need to pass it x as well. Alright, a lot of moving parts. Let's see what it says. Well, dereferencing a void pointer. That's right. 44. Well, since both are void pointers, we should just be able to do this, right? 48. Yes, that should definitely not be there. Right, 63. These should be pointers too, of course. XP is equal to X, assignment from void start to from int32 makes pointer from integer without a cast. Shouldn't void pointers be able to point to anything without having to cast stuff? Isn't that kind of the point of void pointers? GCC has been very much hassly as of late. Pointer, targets, and passing argument print args differ in signedness. The string that we produce is a regular char. So we need to cast it like this then. And it's compiled. Will it work? Almost. But that's probably my fault. Because I forgot one thing. And that is make args needs to be null terminated, right? But we're still one off. But as you can see, we have the variable name here, which is kind of cool. Alright, so the first becomes 0. Let's see. We have the arg C at this point. So this is the last thing. And the last thing well, we're setting the last thing inside of the A structure to the last thing in our intermediate structure. So there might still be a reversed order, I guess. Maybe we should print the values too. I will just add that temporarily because we don't know the type of the values when we use this later on. But in this example we do, so we should be able to do something of the sort. Well, we want to produce an integer by dereferencing this a argv n. But will we run into this dereferencing void pointer again, or will it accept this cast? Well, we'll see. Dereferencing void pointer. So, I guess we need an intermediate variable again. Can we just do this perhaps? Something like this? No? Let's see, x is equal to, well, I guess we need an x pointer too then. So the x pointer should be equal to this, cast into an int star. And then we can just dereference that, I guess. So we don't need the actual x. Let's call this x instead. Something like that, perhaps. Getting closer. Pointer targets in assignment from int star to int 32, different signedness. Right. This should probably be int 32 here then. Okay, compile. but it crashed. Well, it tries to dereference the 0. Maybe we should do something like if we have an A argv n, which is not 0, then we do this. Otherwise, we just do 0. Everything is 0 now. A argv n. Starts with a B. Is it because we're sending the stack addresses? What happens if we simply do X, Y, Z and give the references instead? Will it make a difference? That's false. Isn't that pretty much exactly what we did before? And it's false early because we don't get any output. What does GDB think about it? Inside of make args, we try to move into whatever inside of EDX from EX. And EX contains this, which contains What does edx contain? That's some kind of stack address. Well, we saved the code, didn't we? argsp, and we dereference p. And in our case, we do not dereference. We just copy the memory addresses. And why does ex contain this thing? What is this? Is that a string or something? Maybe. And it's weirdly aligned with a 7 at the end. CC. Well, maybe we shouldn't troubleshoot this syntax too much, because we are not going to use this anyway like that. We are only going to use this with proper pointers. So let's troubleshoot this instead. And then we're back at all of these zeros. And these are almost the same. They only differ by 1 byte. That's weird as well, isn't it? What would happen if we just did let's see. If we instead of doing this 0x thing, we do %p for pointer, and we don't cast this thing, will we still get these weird addresses? Yeah. So that this is actually what we copy into the array then. Maybe it's something which is some leftover or something. We never zeroed out the thing we malloced when we created this thing. So maybe we should. So we need to create a zero function. So it's going to be a void function, and it's going to take an int 8 star and an int 16 for the size. So by the way, we need to cast that 2 then, because size is a 32 in our case. It's just too much, perhaps. Let's do it like this. And how do we create a zero function? Well, there are multiple ways of doing that. By the way, before I forget, we push EBX, but we never put it back. So we need to do that so we don't mess up other stuff. We need to pop EBX. Maybe we shouldn't create this zero function my ordinary way with pointers and loops. It would be kind of nifty to actually use the rep stas Asm instruction directly, which is a CPU instruction which does exactly this. It fills an array with one single value a number of times. So let's see, we have an int 8 star. What do we call this? Well, let's call it a string. Or maybe buff. And then we have int 16 size. Let's check the manual page for rep stars. So let's see, rep stars. It's one of those. Field is 6 bytes. It's 6 words. Well, it's the first one then. Fill ECX number of bytes at ES EDI with the value AL. Okay. So we just need to fill in a couple of registers and then call repstars without arguments. Well, I guess we can do that. Let's copy one of these lines, because the syntax of interacting with assembly is quite weird sometimes. And I'm talking about this %0 equals R, blah, blah, blah. I wonder if R is read and that we should do write. Well, I guess we'll see. It can also be register. Alright. So let's start with pushing all the stuff we want to save. So maybe we should do it simply by just doing a push AD that pushes all of them, basically. Then we want to put into ECX So first we need to empty it. Let's do an XOR ECX with ECX. That will zero it out in an optimized kind of way. Then we want to move something into ECX. No, not ECX, just CX, because we want to move one word. Since this is a 16-bit thing. And now to this percent kind of thing. So So if R is register, this should be V for value perhaps. No, that cannot be it. Let's try R first, see what happens. And then we give the variable name, which is size. Okay, so that should take care of the ECX. Then we need to put the address of the thing we want to edit inside of EDI. So, and in this case, we are dealing with 32-bit things, so we don't need to zero it out first. So we can just move a whole D word. And we move it into EDI. And let's try R here as well, followed by the buff. And now we need to choose what we want to fill it with, and that's a 0. And that an AL decides that. And part of AL is EX, so we can just zero out EX with XOR. EX, EX. And then we have all the components. So now we can call rep stas. Do we need to specify which kind? Yes. We need to type the B for bytes. And when we have done that, we want to reset the registers, so we pop everything again. And we return. Kinda cool function, huh? Just telling the CPU to do it for us. But I'm not sure about these R's, so let's see what happens with those. No such instruction, push AD, pop AD. Maybe we just, this is what they are called inside of Anasm, but, or maybe it's not, but Anasm in particular, but in Intel syntax. But in AT&T syntax, maybe it's just called push A. That's not the same, is it? Let me just try one thing real quick. Let's create a temporary file abc.asm with with two actually instructions, and we do push ad like so, and asm dash f bin abc.asm dash o abc.bin. Very short file, no magic. It's kind of funny. Well, I don't want it to be bin, by the way. And if we're going to produce an elf, we need some more stuff. At least we need to have a global start and a start. Elf abc.o. And now we should be able to do objdump abc.o. It's called push A here, even though I called it as push AD. And what if we were to, let's see, objdump. If we objdump it without Intel syntax, it says push A all over, but that should be, I wanted to push everything, not just that. AX, CX, DX, BX, SP, BP, SI, DI. It seems to be 16 bits. Reference the same opcode. Alright, so let's try the push A instead then. And I guess it's the same for pop A. Number of operands mismatch 21. Oh, push A. Operand mismatch for move D. That's weird. But I guess we can just do move there. Okay, compiled. But will it work? No, it will not. Let's just see if it's this function that causes it. Yep. So maybe this R kind of thing is not what we want. Let's check the official GCC manual. Output operands, input operands. Okay, so we have input and output operands. And we have used all of them as output operands. And they probably should be input. So we need to specify an empty input value then, I guess. Let's see what this equals R means. symbolic name, constraint, expression. Input constraint strings may not begin with either equals or plus. A register operand is allowed provided that it is in a general register. So I suppose in this occasion this should be an M then. But in this case it should probably be R. Let's try I for this one. And I'm not sure what the equal sign, maybe that defines an output operand. Output constraints must begin with either equal. Okay. So let's remove. I think this should be right then. Okay, we need to consider this as well. Or maybe we should just do R there. Okay, it compiled. Huh, cool, it worked. It actually worked. I need to try it on something to make sure. Let's say int8 str, and then we string copy into str hello. Maybe we should define this like this. And we print it. Then we zero it out. And then we print it again. And exit. It works. So this code is the same as memset, basically. But we still have the same trouble with our real code. If I just remove this stuff, and where is that x variable that it keeps complaining about? It's this, I think. Okay. Alright, so this is the problem we need to deal with. But this will be all for today. If you like this episode, please like and subscribe, and we will continue this project in a later episode. Thanks for watching. Thanks for today.